Hello everyone, welcome to my YouTube channel. In this video, we are going to discuss some questions from engineering mechanics, and the topic is forces and resultant force. The first question is, physical quantities having both magnitude and direction are called. Option A, standard. Option B, scalar. Option C, vector. Option D, both A and C. Vector quantities are those physical quantities that has both magnitude and direction, and also obeys triangle law of addition or parallelogram law of addition. Okay. Some examples are velocity, acceleration, etc. Scalar quantities are those physical quantities that have only magnitude. Some examples are temperature, work, etc. So the correct answer is option C, vector. The physical quantities having both magnitude and direction are called vectors. The next question is, two vectors are equal if they have option A, same dimension, option B, same magnitude, option C, same dimension, magnitude and direction, option D, same direction. Two vectors are equal if they have the same dimensions, magnitude and directions. So the correct answer is option C. Two vectors are equal if they have same dimension, magnitude and direction. The next question is, which of the following statement is correct? Option A, a force is an agent which produces or tends to produce motion. Option B, a force is an agent which stops or tends to stop motion. Option C, a force may balance a given number of forces acting on a body. Option D, all of the above. Now, a force is a push or pull that produces or tends to produce, destroy or tends to destroy motion of a body. Therefore, the first two sentences, which are a force is an agent which produces or tends to produce motion, and a force is an agent which stops or tends to stop motion, is correct. Also, a force can balance a given number of forces acting on a body. Therefore, the third statement is also correct. Therefore, the correct option is option D, all of the above. Now, if a force balances a given number of force, then this force is known as equilibrium, because this force will bring a set of forces to equilibrium. The next question is, a force while acting on a body may, option A, change its motion, option B, balances the forces already acting on it, option C, give rise to internal stresses, option D, all of these. Now we have seen that a force is a push or pull that produces or tends to produce, destroy or tends to destroy motion of a body. Now a force also can balance a given number of forces acting on it, and a force also can give rise to internal stresses in body. Okay, therefore the correct answer is option D, all of this. A force while acting on a body may change its motion either by producing or tending to produce motion, or destroying or tending to destroy motion, and it can balance the forces already acting on a body, or it can give rise to internal stresses in it. Okay, the next question is, in order to determine the effects of forces acting on a body, we must know option A, its magnitude and direction of the line along it acts, option B, whether push or pull, option C, point through which it acts on the body, and option D, all of this. Now, a force is a vector characterized by magnitude, line of action, which indicates the direction, and the nature of force, whether it is push or a pull, and also the point at which the force is acting. Therefore, in order to determine the effects of force acting on a body, we must know all of these mentioned here. Okay, we need to know the magnitude and direction of the line along it acts, and we also need to know its nature, whether it is push or pull, and also we need to know the point through which it acts on the body. Therefore, the correct answer is option D, all of the above. Now the next question is, effect of a force on a body depends upon its option A, direction, option B, magnitude, option C, position, option D, all of the above. We have seen in the previous questions that the effect of a force depends upon direction, magnitude and position of the force. Therefore, the correct answer is option D, all of the above. Now, the next question is, force is a option A, scalar quantity, option B, vector quantity, option C, sometimes scalar, sometimes vector, option D, none of the above. Force is a vector quantity which has both magnitude and direction and also obeys triangle law of addition. So force is a vector quantity. Option B is the correct answer. The next question is, the dimensional formula of force is given by option A, mlt raised to minus 2, option B, ml square t raised to minus 1, option C, ml raised to minus 2 t, and option D, ml raised to minus 1 t square. Now force is given by mass into acceleration. Now taking the dimensions of force is equal to dimension of mass into dimension of acceleration. The dimension of mass is represented by capital M, and we know that the unit of acceleration is meter per second square. Therefore, taking the dimension of acceleration, we will have lt raised to minus 2. Meter represents length and second square represents t. Second square is in the denominator, so t have the power minus 2. So combining, we have the dimension of force is equal to mlt raised to minus 2. So the correct answer is option A. The dimensional formula of force is given by mlt raised to minus 2. The next question is, a retarding force on a body. Option A, changes the motion of the body. Option B, retard the motion of the body. Option C, introduce the motion of the body. And option D, none of these. A retarding force acts in the opposite direction to the motion of an object, opposing its motion and slowing it down. Therefore, it retards or decelerates the motion of the body. The correct answer is option B, retard the motion of the body. So a retarding force on a body retards the motion of the body. Next question is, unit of force in SI unit is. The unit of force in SI unit is Newton. Therefore, the correct answer is option A. Unit of force in SI unit is Newton. And 1 Newton is the force acting on a body having a mass of 1 kilogram and has an acceleration of 1 meter per second square. Dyne is the unit of force in CGS system. And for your information, 1 dyne is equal to 10 to the power minus 5 Newton. Now, when 1 kilogram of mass is attracted towards Earth with an acceleration of 9.8 meter per second square, which is acceleration due to gravity, the force will be mass into acceleration, which will be 1 into 9.8 equal to 9.8 Newton. And this force is called as 1 kilogram force or 1 kilogram weight. Okay, when 1 kilogram of mass is subjected to an acceleration due to gravity, then the force on it is 9.8 Newton, and this is called as 1 kilogram weight or 1 kilogram force. Now the next question is, the unit of force in CGS system of units is called option A, dyne, option B, Newton, option C, kilogram, option D, none of this. We already have seen that the unit of force in CGS system is dyne. Therefore, the correct answer is option A, dyne. The unit of force in CGS system of units is dyne, and 1 dyne is equal to 10 to the power minus 5 Newton. The next question is, 1 kilogram force is equal to option A, 1 kilonewton, option B, 8.91 Newton, option C, 9.81 Newton, option D, 981 Newton. When 1 kilogram mass is attracted towards Earth with an acceleration of 9.8 meter per second square, which is the acceleration due to gravity, then the force acting on it will be 9.8 Newton, and this is called as 1 kilogram force. Okay. So 1 kilogram force is equal to 9.81 Newton. Here the acceleration due to gravity is sometimes taken as 9.81 Newton, and sometimes it is also taken as 9.8 Newton, depending upon the accuracy with which we need. Okay. The next question is 1 Newton is equal to option A 10 raised to 4 dynes, option B 10 raised to 5 dynes, option C 10 raised to 6 dynes, option D 10 raised to 7 dynes. We know that the dimensional formula of force is mLT raised to minus 2. Now the unit of force is 1 Newton in SI unit, which is equal to, substituting the corresponding unit for mass, length and time, we get 1 kilogram meter second raised to minus 2. We know that dynes is the unit of force in CGS system. So in CGS system, the base units are centimeter, gram and second. So converting 1 kilogram to gram, we need to multiply it by 1000, and in order to convert 1 meter to centimeter, we need to multiply by 100. So we'll have 10 raised to 5 gram centimeter second raised to minus 2, which is equal to 10 raised to 5 dynes. Okay. So the correct answer is option B. 1 Newton is equal to 10 raised to 5 dynes. Now the next question is 1 Newton is equivalent to option A 1 kilogram weight, option B 9.81 kilogram weight, option C 981 dynes, option D 1 divided by 9.81 kilogram. We know that 1 kilogram weight is equal to 9.81 Newton. Therefore 1 Newton is equal to 1 divided by 9.81 kilogram weight. Therefore the correct answer is option D. 1 Newton is equivalent to 1 divided by 9.81 kilogram weight. The next question is, the principle of transmissibility of forces states that when a force acts upon a body, its effect is option A same at every point on its line of action, option B different at different points on its line of action, option C minimum if it acts at center of gravity of the body, option D maximum if it acts at center of gravity of the body. The principle of transmissibility states that if a force acts at any point on a rigid body, it may also be considered to act at any other point on its line of action, provided that this point is rigidly connected with the body. Therefore, the correct answer is option A. The principle of transmissibility of forces states that when a force acts upon a body, its effect is same at every point on its line of action. Now the next question is, the force acting on a point on the surface of a rigid body may be considered to act option A at the center of gravity of the body, option B on the periphery of the body, option C on any point on the line of action of the force, option D at any point on the surface normal to the line of action of the force. From principle of transmissibility, we know that if a force acts on a point on a rigid body, then we can consider the force to act on any other point on the line of action. Okay, so the correct answer is option C. The force acting on a point on the surface of a rigid body may be considered to act on any point on the line of action of the force. The only condition is that this point should be rigidly connected to the body. Okay, so that the effect of force is the same. That's all. Thank you.